Hey, welcome to day 18. You should really be proud of yourself for making it this far in the course. Taking online courses and learning a new language is really challenging and takes a lot of courage to do. So congratulations for making it this far. Before we begin with today's content, let's make a recap of what we did yesterday. So this is what we have done so far. Yesterday we added the add button and the edit button, so now we can add new to-dos in our app and we can edit to-dos. To add these two buttons we used a while loop in conjunction with a match case block. Today you'll learn how to add a complete button to mark to-dos as complete and remove them from the list. Plus, you learn how to create an exit button as well, which exits the program. Instead of clicking that button, the user should also be able to press the exit button for a more user-friendly exit of the program. So let's do this. I'll see you in the next videos. So far, we have developed this program. We have this add button and this edit button. In this video, we're going to add a complete button next to the edit button, and also an exit button somewhere down below the list box here. The complete button will delete the selected to-do, so we select a to-do, press complete, the to-do is deleted from todos.txt and also from this list box. While the exit button will close the program, so the exit button will be an addition to this button. Both that and the exit button will close the program. Let's begin. Let's ignore this error for now, we're going to fix that also later on. So let's look at the current layout. We have the label in one row, then we have the input box and the add button in another row, and then in the third row we have the list box and the edit button. Here we want to also add a complete button in the same row, so to the right of the edit button. So let's create that complete button. Under edit button, we declare a complete button. So that is the same variable name as this one. And this is going to be again a button with a label complete. Now, since this line is getting too long, I want to split it into several lines. So it would make sense to have one row in one line. So we have the label row, and then we have this row with the input box and the add button. And then after the comma, here I split it again. So one row, two rows, three rows. Let's run to see what we have. Yeah, so it looks fine. Edit and complete. Now, we should add a case complete. So we have case add, we have case edit. Let's add a case complete. So complete is the label of the button, this one in here. When the user presses that button, complete, that string is stored in event and this variable in here. So we match that event. If the event is complete, what do we want to do? Well, we want to delete the given item. So first we want to get the to-do to complete, just like we did for edit. We got the to-do to edit from values to-dos. So which means that when the user selects, for example, get the car, that dictionary is the values variable, so we extract that list out of that, and also we extract that string out of that list using 0, this index operation. And now we want to remove that to-do from todos.txt. So first, we get the to-dos from todos.txt using functions.getToDos. This will give us the list of current to-dos inside todos.txt. We're here, and then we say todos.remove. So we use the remove method. It's a list method. To-dos is a list, so todos.remove removes a to-do. For example, if we had a is equal to 1, 2, and 3, and we say a.remove 3, that is going to remove item 3. So a now is updated to that. It only has 1, 2, the first two items. So we want to remove the to do to complete. And then once we update the list, we say function.write to-dos, and we send the to-dos list to that write to-dos function, so that the write to-dos function writes that list to to-dos.txt. And lastly, we want to say window to-dos, so this point to the list box instance, this instance. Note that this instance has to-dos as a key, so therefore Windows to-dos points to that list box. So we want to update the list box. We want to place a new value for values. Values is the list of the items. We want to put a new list. The new list is to-dos, the list which is updated from that remove method. So if I run this now and I try to remove get the car, and then I press complete, get the car disappears from the list box. However, it is still in the input box because we haven't updated the input box. So let's update the input box as well. That is window with the key. Let's see the input box, which is the input text. I sometimes refer to it as input box. It has as key to do. Therefore, we say window to do dot update. This has a value argument, not values. It contains one single value, and we want to update it to an empty string. So just write 2 single quotes or 2 double quotes, wherever you prefer. Run GUI.py. Let's remove clean the program. So complete clean the program is removed from the list box. It's also removed from the input text here, and also from to-dos.txt. You see it's not here anymore. So that was the complete button. Now let's add an exit button as well. I said that exit is going to be in a separate line. Therefore, I'll place a comma here in this row and add a new list in here. So notice the brackets. We have this bracket which closes in here. Those are the main out brackets. And then we have the rows, that one, that row, and a third row here. This is going to be an exit button, which should be created in here as g.button exit. And then we go down here to add a case exit. So that is the label of the button. So if the user presses exit, exit is going to be stored in the event variable. So we check if the event is add, edit, complete, or exit. And if it is exit, we break the loop. So let's try. There we have exit, we press exit, and the program exits. If we press this button, now we don't get that error anymore that you saw previously. So that also fixes that error. Before we close this video, let's not forget to commit. So press that button and implement the complete and exit buttons. You can commit that message. If you like, you can also push the changes if you want to synchronize them with GitHub. It's fine to push the changes just after a few commits, but this is also fine, especially when you're learning. So if you want to push them, just push them on GitHub. There's no harm done. So with that, I'll see you in the next video. Thanks. Hey, welcome back. I'm very excited to tell you that in this video we're going to finish the development of our program. Exactly, we're going to do 3 things. First, we're going to fix a couple of errors that we have. We're going to handle them using try and except. Second, we're going to add a live date and time with a seconds ticking on the GUI. And third, we're going to polish the program, change the theme of the program, play around with the sizes of the elements and so on. Let's begin by fixing the errors. So when the user runs the program and without selecting anything they press on edit, then we get this error, index error. That is because in line 34 in here, this values is a dictionary. So it is this dictionary. and values to do's gives us this list. So we access the value of to do's, which is a list, and then this part tries to access the first item of that list, you see, with index 0. But there is no such item because the user hasn't selected any items from the list box. Therefore we get an index error. As you might know already, to handle errors we use try and except. So we're going to indent all that block and place it under a try statement, and then go here, unindent, so that you are in the same level with try, and say except, and look at the error we got. So it's an index error. And let's try first to print out something, such as please select an item first. Let's try this. Run GUI, edit, and we get the printing successfully executed. So the try except block is working. However, note that when we create this GUI programs, what the user will see is the actual GUI. They will not see any command line interface. Therefore, any messages that you show to the user, you should show them here on the graphical user interface, or you could create a pop-up window telling them what they did wrong. So let's create a pop-up. I'll close this, and instead of printing this out, we want to use the sg.popup. So sg is simple GUI, and popup is a function of that module. So if you right click here and go to implementations, it's going to take you to the function definition, to the popup function definition. This is the docstring, all that in green, and then that's the code of the library. So the library is written in Python, as is the case with all third-party libraries which you install with pip. So let's try to run this and see what happens. Press on edit and we get this window. So it says please select an item first. The user can close it, can press OK. We can make that pop-up window bigger by applying a font argument. So just like this window method has that font argument, the pop-up function also has that font argument. So this gets the font, family, and the size. Right click, run GUI, press on edit, and that's the window, so it looks better. We have the same issue with complete, the complete case. So if the user presses complete without selecting an item, we still have an error here. So let's quickly do the same here. Indent, try it on, except this is also an index error, and I'm going to copy that and paste it here. So let me put this in here, run, press on complete, and we get this window popping up. So it's working fine. Right, so that's about error handling. Next, what we want to do is, on top of this label, as the first row, we want to add the current date and time. So let's do that. We set on top of this label. So we want to create another label here. Label is equal to sg.text. First, we leave it empty, and then we update that sg.text, that label object, which actually needs to be a different name. So we have that label variable there. So let's call this maybe time or clock, because you don't want to use time because we're going to import time. So this is the name of the module we're going to use. Therefore, don't use variable names which have the same name with keywords, modules, objects, functions, etc. So just use something like the clock. So we import time because, as you know from our previous command line interface, we use time to get the actual time with that strftime function. So when do we update that text? Well, we update it somewhere in here. So after we apply window.read, we say window, and we point to this clock instance. We should give a key to that so that this clock has an identifier. So let's say clock, and that clock now should be mentioned in here. Here we are. Yeah, clock. So that accesses the window clock, that label, and we update the content of that label. The current content is an empty string, as you see here. So we update that to value time.strftime. So we call that method actually, and that was this one. So let me copy that, go to GUI.py, and we are here. So that's it. The new value is going to be the output of this method, and the output of that method is the time and the date. And let's make sure that we have added now this clock instance to the layout here in SG window. So we said we wanted to add another item above label. Therefore, this is going to be a list, and inside the list is clock. Let me indent this, and don't forget the comma here. So that should be fine. Let's run the code. Now we have this space here, but it's still an empty string, so the time somehow is not being displayed. To fix that, you want to go to window.read and say timeout is equal to 10. Run again, and now we see the time. There we go. So it's working, and you can see in the command line that now this while loop is being executed every 10 milliseconds. We had to apply a timeout because otherwise the loop runs only when an event happens, when the user presses some buttons and so on. But when you apply that timeout 10, then the loop runs every 10 milliseconds, which is a fraction of a second. Therefore, that continuous running will allow this part here to be executed every 10 milliseconds. And that makes it possible to see the actual time here updated every second. You see, you can also get away with another bigger value, such as 200. So a second has 1000 milliseconds, so 200 is still less than a second. And it's not displaying. Let me run it again. So 200 is also fine, and it's also better for the program because it's not running so heavily every 10 milliseconds. Right, I'll leave it as it is, and I'll delete these now. We don't need these anymore. We don't need to print them out in the command line. So those print functions were printing out these lines. And lastly, let's change the theme of the program. To change the theme, you want to apply sg.theme. So what theme can you apply for your program? Well, if you go to Google and search for Simple GUI themes and go to images, then the first image, you can click it, you can open it, and that should give you all the available themes you can apply. For example, if you want dark purple for this one in here, up here, then you'd want to write here dark purple 4. So run GUI, and that's what you get. I think the black theme is fine. So I hope you agree with me. Otherwise, just find one of the themes on the page I showed you. Lastly, I want to talk about the sizes you give to your widgets. For example, we used size equal to that list, which has two elements, two numbers. That was the size for the list box. Now, how do I know what size to give here, and how can you know? Well, for such things, you don't even have to ask me. You can right-click over list box, go to implementations, and then look at the size description in the docstring. So you see the triple quotes here. So if you scroll down somewhere here, that's the size, and on the sides here is the description of the size parameter. So this is saying that this size has white as the first character. You see down here, it's supposed to receive two integers. The first one is going to be the width, and this is the number of characters. So what I'm giving here for the list box is 45 characters wide. So that means the width of the list box is equal to 45 characters. And 10, as you can see here, 10 is the height in number of rows. So this program now is like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 rows high. That's how sizing works for all the widgets, not only for the list box, but for other widgets as well. And it also says something else. If an int is instead supplied instead of a tuple, then the height is set to 1 by default. So that means you can also give, for example, for a button, you can give the size equal to 10. And you see that the button is now wider. However, the height doesn't change because the height is by default 1 row unit. And that's the idea also about our program. One last tip before we close the video: if you are using PyCharm, I do suggest you to use the Rainbow plugin, which you can install by going to Settings and then going to Plugins and then going to Marketplace and search for Rainbow, install it, then restart PyCharm. And what that plugin does is it colors the brackets, parentheses and brackets. So now this yellow parenthesis corresponds to that yellow parenthesis. So the code is visually more readable. You see that this green bracket closes here and so on. If you are on another IDE other than PyCharm, perhaps you could Google something like Rainbow Alternative for Visual Studio Code or Atom, whatever IDE you're using, and probably there is such a plugin for your favorite IDE as well. So I wanted to show you this because from now on the code is more complex, such as this one in here. So it is helpful to see more emphasized syntax highlighting. Let's also commit the changes. Change theme, add clock, handle, edit and complete errors. That's what we did. So commit, and then I'm going to push the changes to GitHub. So with that, we are done with our program. It was quite a long journey to build this first app, and it was a bit slow because this was the first app and I had to explain you a lot of concepts. I had to explain you the features of Python, the types of objects, functions, etc. So for the next apps, now we have a common language. You know what type is. So whenever I build something, I just tell you that, oh, this is a type and this is an instance, and we use that for this, and everything is going to be much easier than it was. It's also going to be more fun with the next apps, because this app was basically simple. We just had to work with text, so the to-do items were text, but we're going to work with more interesting data formats later in the course, such as PDFs and images, graphs, etc. So all that can be handled with Python, and it's a lot of fun. So stay tuned and I'll see you in the next videos. Bye. Hey, welcome back. In today's code experiment session, we're going to experiment with the buttons. Specifically, we are going to use images as buttons. So in my project directory, I have these two PNG images. You can find these attached in the lecture resources in this lecture, so please get them and place them in the same directory with your GUI.py file. Now, if you prefer, and I do recommend that you create a separate project for experiments if you don't want to modify the existing program. Because in my case, I'll do some experiments, but then I'll just undo the changes and just go ahead and just continue with where we left the program in the video, in the last tutorial. Right, so I assume you have the code and you have these two images in the same directory with the code, and then to use an image as a button. For example, let's look at the add button, this one in here. You want to first remove the label, leave the size for now, and then add an image underscore source argument, which is equal to the path to your image file. In my case, it's add.png, since this image is in the same directory with GUI.py, this script. So I want to first stop the script and then run it again. And there you go. So that's the new button. Now it's replaced with that image. This does have some issues though. One of them is the button is a bit wider. The second issue is the button disappears when we hover the mouse over the button. And the third issue is that the user might not understand what this button is about, so we want to show a tooltip. So let's fix all these three issues. The size first. Close the program and try a size of 2. Run again. And if you're satisfied, then that's what you should be using as the size. The second issue was that the button is disappearing where we place the mouse. To fix that, you want to add a new argument. So we have size, we have image source, and add a third argument called mouse over colors. As a color, you can place any of the supported colors, which you can find on Google if you search for py simple GUI colors, and you open these images. So they should have different colors. For example, light brown. You see here light brown. I can use it as a string, light with capital L and capital B, brown. So if I run the script now and I hover the mouse here, you know, the button doesn't disappear, but this is not yet ideal. So you want to find something that is better than that. I know that light blue 2 will fix the issue. You see now, the button gets a tint of blue when I hover the mouse, and then it turns back to white when I remove the mouse from the button. So that's a better user experience. And lastly, let's add also a tooltip. I'll do that in the next line. So after the comma, I press enter, and then I add tooltip is equal to add to do, for example. Run, and then if I place the cursor over the button, I get this tip, so telling me what this button actually does. But if you write something here and you press that button, it's not going to work. That is because we removed the label of the button. And here match event is trying to match the add string to the event variable, but such a string doesn't exist anymore as the label of the button. But that's what the keys are for. So you want to add a key, name it add, and so now case add will check for an event equal to key. So the event takes either the label of the widget or the key as a value. So we'll run GUI, improve the app, press the button, and improve the app is added here. And that is how you can create image buttons. As an exercise, you can also implement the complete button. If you like, I gave you the complete.png file already, so it's attached in the lecture resources. And of course, the process would be exactly the same as we did with the add button. So thanks for following and see you later. In yesterday's bonus example, we built a zip creator program. Today we're going to do the opposite. We're going to create a program which extracts a zip file to a destination directory. So this will be a new program, and therefore I want to take advantage of this opportunity to explain you once again the steps of building any program. And so we're going to go through these 4 steps in this video. So if your ideas were scattered before, you didn't know where to start, this video will make sure that you have a clear understanding of where to start a program and how to finish it. So let's start with the first point, designing the front end. Now this can mean different things. If it's a simple program, you can just use a piece of paper where you make a drawing how your app front end will look like. If it's a more complex program, you can use software such as Figma, which we'll cover later on. So Figma is a software which allows you to create designs for your apps before you build your apps. Usually you create a design for graphical user interfaces, which could be desktop apps as the one we're building, or web apps also. Later on we're going to build web apps in the course. So usually you don't do this if it's just a command line interface. That's because graphical user interfaces are more involved, so it's good to have some drawing beforehand before we go ahead and build the actual interface with Python. So in our case, the program would look something like this. Here we have the default buttons of any window to close, minimize, and maximize the window. So these are created by default by PySimple GUI. And then in this area here we have the title of the window. Such as archive extractor. Then we're going to have a label, select archive, the input box, and the button, choose. Another label, select destination directory, another input box, and the button, choose. So what we have here is the input box where the path of the archive of the zip file is going to be placed. So we choose a file using that button, and the path of that file will be rendered here as text in this input box. That's a common practice when you pick files using a file picker, such as this button here. The same we have here, but in this case this will be a directory. This will be the directory where the files of the zip file will be extracted. So again, we have an input text and a folder browse button. So that is a file browse button and that is a folder browse button. And finally, we need to give the user an extract button down here as well. And that's it. So that's the front end. So the next step then is to code the front end. So you might want to keep the design open somewhere while you do the coding part. So I'll just keep it here and then create a new bonus18.py file. So that's the file. It's in my bonus folder and I'm going to import free simple GUI. I'm going to be quick with this app. I'm not going to type in all the code because we already did most of this code in the previous app yesterday in bonus examples where we built the zip creator program. So you know what this code does. So we set the theme of the program as black. So SG is py simple GUI, the module. And then I'm going to create the widgets in here. So there we go. We have a label. The first label, select archive, which is going to create this label here. And then next to select archive, we're going to have the input box. So that creates the input box. And then the choose button, the first button, which is a file browse. Yesterday we had a files browse. You see it's plural, files. Today we have file. That is because today we only want to select, we only want to let the user select one zip file only. Yesterday we wanted the user to select multiple files if they wanted, so all those files would be put in a zip file, but now we want to let the user just select one file, not more. In that case, we use file instead of files. Right. So those were the widgets of the first row. And then we're going to have the widgets for the second row. So I'm going to paste them in here. We have the label, select this directory, this one here. And then we have the input box. And then next to that, we have the choose button, which is going to be a folder browse instance. So with that name, choose, and we have the key for that button, and we have the key for that other button as well. Archive for this, folder for this. So later on, we can refer to this to get the actual paths of the files. And lastly, we're going to have the last row. So that is the extract button, this one in here. And next to the button, we're going to display the text extraction was successful. So that means there will be a second state of the interface where we're going to show here extraction completed or something like that. So for that we have a text widget which doesn't have a label, so it's an empty string. It does have a key and it does have a color for the text, but currently by default it is an empty field, as you see in this first interface here, in the first design. And once we have created the widgets and we store those widgets in variables, we can create the window instance with asg.window. That's the title of the window which corresponds to that. And then we have the layout argument, which is a list of lists. So the list has lists inside, and each inside list represents a row. So we have the label, the input one, choose button one, which will create that first row, and then the second row of the interface, and then the last row where the extract button is and the output label. which by default is empty. So we are about to complete step number 2. All we're left to do is just read the window and then apply window.close and then run the program and see how it will work out. So that's the interface. It looks similar to the one we designed. So that completes coding the front end. So design the front end and code the front end are completed. Now we work on the back end. So step number 3. For the backend, as I have explained you before, it's good to create a separate file. So under bonus, where bonus 18 is, in the same directory, I want to create a zip extractor.py file. We're going to use the zip file standard module. So you don't need to install that module. And we need a function, extract archive. In our program, we get as input the archive path, and also we get as input the path of the destination directory where the files will be extracted. So that means the function also will need 2 parameters. File path or archive path, let's say archive path, and destination directory. So the next question is, what do we do with these? Well, we're going to get that file and we're going to extract it in that directory. So for that we need to use with zip file archive path. So here goes the archive file, and then the second argument of the zip file is read. Before we used write. When we wanted to create a zip file, we used the write argument. But when you want to see the contents of the zip file, then you want to read that zip file. Therefore, we use read for that. So that would be as archive, perhaps. This is just a variable name. So don't confuse archive with archive path. Those are 2 different names, different variables. The first one represents the path and the second one represents the actual file object, a file entity, not a file path. A file has a path, but they are not the same. And then we point to that file, to that zip file, and then we point to extract all. We extract everything in the destination directory. And that's it. So now we are almost done with the backend, with the third step here. But we also need to test this function before we go to the next step, finishing up, which is going to be connecting the front end to the backend. So first, let's make sure that this backend works. For that, we need to use if name is equal to main, so double underscore, double underscore, double underscore, double underscore. So this, as I explained before, this allows us to run the script as the main script like this and get that output. So this function will not be called when the file is imported as a script, as a module in the other main file, bonus 18. So this is only executed when we run the script now. Okay, extract archive. Let's give some directory. So in my bonus directory, where this zip extractor file is, I have this compressed zip file. So please download the compressed.zip file from the lecture resources and put it in the same directory with your zip extractor and your bonus 18 files. But if you want, you can use your own zip files if you have something. So in my case, it will be compressed with .s.zip. So that has to reflect the actual file name exactly. And the destination directory is going to be an existing directory. For example, I have this files directory which is inside bonus, but this can be any directory. However, it is important that you give the actual absolute path of that directory. So in my case, I want to go to right click and copy path reference, and I want to copy the absolute path. And then I want to provide here that absolute path which I copied. So that's the absolute path. And it's a good idea to actually use the absolute path for compressed.zip as well, because these paths are also going to be absolute paths in the GUI interface. So for compressed as well, I can right click, copy path reference, absolute path, and then replace that with the absolute path. And I'll split here because the line is too long. So I'm calling the function, and I expect that the files will be extracted in this files directory. So let me run zip extractor. Yeah, there we go. A.txt, B.txt, and C.txt. These were the files that were inside that compressed .zip archive. So these are just empty files, but it's working, and that completes step 3. And we move on to step number 4, finishing up. What does this mean? Well, this means connecting everything together and completing the program. So it means connecting the front end to the back end, because currently the front end is just a static program which doesn't do anything. Therefore, we want to bring it to life using a while true loop. So we store event and values in window.read. Window.close stays outside. Let's print event and values to see what we actually get. So run bonus 18, choose the archive. So that should be the compressed.zip file. It can be anywhere in your computer, and the directory also can be anywhere. So I'll just choose this directory, and if I press on extract, now I'm going to see that I've got extract as a value of event, and then this dictionary. So the dictionary has this archive key with its value. The value is this one in here. So that the value is a string, one single string, and it represents the path of the zip file, the absolute path. And we also have the folder key and its value. And its value is the absolute path of the destination directory. So in other words, archive path is stored in values. What was the key again? It was archive, yes, which corresponds to that. And so that is the archive path, and the destination directory path is values. Was it folder? Yes, folder. So now we are storing that string in here and that string in here. That allows us to call the extract archive function, which underlines in red because we need to import it from zip extractor import extract archive. And then we use the function and we pass archive path as the first argument and test directory as a second argument. So that value goes in here and that value goes in here. So these two strings are going to be used in here. And the function will do its job. And then lastly, we want to point to window, output that hidden label and update it by setting its value to extraction completed. And let's run. Select archive, that will be the compressed.zip file. Select destination directory, that is going to be this directory. Extract, extraction completed, so I can check dest, and these are the three files. They were extracted in that destination directory, and that is the complete code for this app. And that's also the steps we took to create this app. So basically these are the steps for any app that you want to create. So start with designing the front end. It's good to know what the user will see first, because that could also define what we do in the next steps. So the user is important because you are creating the programs for the user. So you want to satisfy the user's need. That's why it is important to have the design first, and then we code the front end, and then you code the back end, and then you connect everything up. So thanks a lot for following this. I'll see you later. I have a question for you. What if you wanted to give your program to another person so they can use your program? What would you give to them? Well, you could give the .py file, and the problem is that they need Python installed on their computer to be able to run the program. And that's not the best user experience. So as you might know, normally we get executable files for apps that we use daily. So these are standalone executables, and it doesn't matter what programming language was used to write that app, the app will work in any computer. So in this video I want to show you how to convert your Python scripts, your Python programs into standalone executables which can run on Windows, Mac and Linux. So before we begin, we want to make sure that the program is working well, so maybe try to run the program and see if there are errors. If there are no errors, then we're good to go. However, there's something we need to think about. That is the external file that we have, which is todos.txt. The way we use this program is that this program is dependent on this todos.txt file. So if the file does not exist, so if we delete the file now, and if we run the program, we're going to get an error. No such file or directory in functions.py in here. So the program is fragile at this point. We need to change the program so that the program is able to generate that file if that file does not exist initially. We can very easily do that. So go to GUI.py, import OS, which is a standard library. And then I'm going to use the OS library here. But first let me make you a demo in the Python console. about OS. So if I import OS, then what I'm trying to use here is os.path.exists, and inside here goes the path to the file you want to check if it exists. So if I execute that, I get false when the file does not exist. If the file existed, so todos.txt is not here at the moment in the project directory, that's why we get false. If it existed, we would get true. We can make use of that and say here, if not os.path.exists todos.txt, so that's a conditional, an if conditional block, and we are saying here basically the negation of that. So if the file does not exist, then we're going to create that todos.txt file. So with open todos in write mode as file, and you can just say pass here. We don't want to write anything in todos.txt. So pass is a statement which basically does nothing. However, we have to write here something because the syntax requires that. So the syntax of the with context manager requires that something should come in this line here. So with this line, now if I run the script and todos.txt file is not there, then todos.txt file is going to be created. So you see now it's there, todos.txt. But if you run the program for a second time, the file will not be overwritten. So basically this will not happen, and that means that this will not be executed when the file already exists. So that means when the user will run the standalone executable, only the first time they run the program, the file will be generated, then the file will be there. With that, we're ready to create executable files. Now the process is different on Windows, Mac and Linux, and if you want to create an executable for Windows, you need to have a Windows computer. The same goes for Mac and Linux respectively. Therefore, now I'm going to start the process of creating the standalone executable on Windows. So if you are on Mac, you can skip and you can jump to minute. If you are on Linux, you can go to minute. So Windows users, let's start. Now, before we continue, we want to make sure that when you open the terminal in PyCharm, somewhere in here it should say venv in parentheses. In my case, I get this error. So something is not working right, and to fix that, so if you get this error as well and you don't get that venv, you need to say set dash execution policy. So set execution policy remote signed with a scope for the current user. Press enter, and then you want to close the terminal. Open the terminal again, and now I get this venv here. So now we can go ahead with the next steps. The next step is to install a third-party library. You can use pip install PyInstaller, or I would recommend, if you are on PyCharm, you can just go to Python packages here and search for PyInstaller in that box. Click on PyInstaller in the list here and then go here on the right and press on install. So PyInstaller is a third-party package, just like PySimpleGUI, but PySimpleGUI is used to create graphical user interfaces, and PyInstaller is used to create executable files, .exe files. Once you install PyInstaller, you can minimize the Python packages pane and go to the terminal again. And now we want to run the command which will generate that executable file, and that is PyInstaller. So we are in the terminal, not in the Python console. This is not Python code, this is a series of commands for the Windows operating system. So this would be PyInstaller one file, so dash one file, space dash Windows, space dash clean. And lastly, you want to specify here GUI.py or whatever name your main Python script has. So that is the script which you execute usually. So usually I do run GUI, which is GUI.py. So that's the script there. PyInstaller is the library, so we want to run that library through the command line here. And these are the parameters we give to that command. One file means it will create one single executable file instead of creating several distributed files. And this is going to avoid having a command line generated. So usually if you don't supply this argument, then what you get is that the GUI that we have created, but also a command line. We don't want that for the user, so they just want to see the GUI. And lastly, clean means that if we generated the file, the executable before, now this clean will override that executable. So even though this is not needed the first time we run it, it's a good practice to use clean there. Otherwise, the next time you execute this, the previous executable file that was generated will not be overwritten, and that can confuse you. So press enter. And this might take a while until PyInstaller creates the executable file. Now the executable file is going to be created in the project directory. And you can see on my project directory that I have this build and dist created just now. And yeah, it's finished on my system. So building exe completed successfully. Now I want to right click over this dist folder and go to open in Explorer. So that's my project directory. If I double click over dist, here we're going to see this GUI file, and that is an executable file, .exe file. So if we double click that, and that's a program. Now it also has this to-dos file in here which has that string, but you can delete that and you can give users only the GUI file. So if I run this now, you'll see that this creates a fresh to-dos.txt file in the current directory. So if I add now to-dos to do one, press on add, to do one is added there. If I close the program with exit, I open it again, the to-dos are there. So that executable file is using that as its database to store the data. So you can give the entire dist folder to the users. These other files do have some extra information about the production of this executable file, but you don't need to give them to other people. So just give them the dist folder or only the GUI file. And that was how to create an executable file on Windows. Next, I'm going to cover how to create a standalone executable file for Mac computers. So that would be a .app file which runs on Mac computers. So that's an application file. Let's begin. To convert your Python program into a standalone executable that runs on a Mac computer, we need to use a third-party software. There are several options out there, but what I'd suggest to use is Platypus. So please search for Platypus somewhere on Google, Platypus Mac, and then you want to go to this page with this URL, sveinbjorn.org/platypus. So this has the installation instructions, which is about installing the program with Brew. So you need to have Brew installed. If you don't have Brew on your Mac, you need to search on Google for Homebrew. And go to brew.sh, and there you'll find the instructions to install Homebrew. Once you have installed Homebrew, then you want to run that command brew install --cask platypus on your terminal. So open the terminal on PyCharm and enter that command. and wait until the software installs. Once you install that program, then start it. It should look something like this. And let's begin to input the parameters here. So the app name, this is going to be the name of the standalone app that you will create. So let's keep it simple, my to-do app. Then you can leave this as it is, but in here you want to specify the path of your Python interpreter. The path of my interpreter is in here. I can find it by expanding the then folder. So I'm using a virtual environment. Then I will expand bin, and then I'll scroll down until I find Python 3. I right click here and I go to copy path reference, and I want to copy the absolute path of that Python 3 file. So that Python 3 is the actual interpreter which interprets the code, which runs the Python codes. So I'll copy that, go back to Platypus and paste that directory there and just leave it. Then we have the script path. This one you can select from here. So press that button and this is going to be the path of your GUI.py file. So in your case, maybe you named it differently, but basically this is the entry point of your program. I've always executed GUI.py to run the program. So you want to select that and you'll see that the path is updated to the absolute path of GUI.py, which is located, as you know, in my project directory here. Right. Next, leave this option as it is for now, text window. If you want to change the icon, feel free to do it by using this button and then select image file. I'll just leave it as it is. Then you have some data. I'll leave them as they are also. And then here, bundled files. Here is where we supply other files that are necessary for our program to run. In our case, the only file that is necessary for this program to run is functions.py. Therefore, we want to go in here and select that plus and then select functions.py. And functions.py will be added in here. I'm not adding todos.txt in here because I want this line to create it from scratch. So it will create a new todos.txt file for the user, so they have a new empty text file which they can add it with their own data. Be careful here, so sometimes this changes to another directory and you see it's in red, so I have to update it again. I'm going to go to venv, bin, select Python 3, right click, go to copy path and then absolute path, and then go back here, paste it again. And now I want to press on create app. So press that button. This will ask you where you want to save the GUI.app file. So that's the executable file that will be created. I'll just keep it here in this project directory, which is app1, and press on create. And that's it. So now I should look for that GUI.app file. So it's here, but I want to right click over my project main folder and go to open in Finder. So go to app1 and there is GUI. So that's a file that was generated. If you click that, it's going to open two windows. Now if you had an issue with your program, then you're going to see an error in this window here. And you're probably not going to see the actual GUI, which in my case, it's working fine. So I can add a to-do, and I see the to-do here, so it's working well. Sometimes it says that PySimple GUI was not found in here. That is the case if you selected a Python interpreter which doesn't have PySimple GUI installed. So in my case, I selected my virtual Python interpreter, which does have PySimple GUI installed because I have already installed it in the previous lectures. So if you also have a virtual environment and you have followed me, you probably didn't have that issue. Otherwise, you might need to install PySimple GUI to be able to fix that issue. But you can ask a question in the Q&A if you have that issue. Right, before we close this, I'm sure that you want to know how to get rid of that window which was displaying on the side of app. You can do that by selecting this and going to none. So it's good to have the text window when you're trying the executable file as a developer, but then when you want to produce it for other people, you don't want to see that. So the text window is only good to see the errors when you are testing things out. So in that case, you want to create the app again. Create. This will ask you to replace the existing GUI.app file. So press on replace. Go to Finder again. Run again. And now it's one single window. The todos.txt file is indeed inside this GUI app. So if I right click and go to show package contents, and then I open this app file as a folder, and then I right click here and I go to resources, there you will find todos.txt. So that's the icon of the app as well, and so on. So that's the app file. And that's how you can create executable files on Mac. Linux users, now we're going to create an executable which runs on Linux computers. So I am on a Linux operating system, so you should be also in a Linux operating system if you want to create a standalone executable for Linux. To create the executable, we need a third-party library for Python. So just like we had PySimple GUI, now we need something called PyInstaller. So for that, you need to either go to the terminal and do pip install PyInstaller, or I would recommend to use the graphical installer for packages, which can be found on settings here, and then in the project, or directly you go here, Python packages, right here, PyInstaller, press enter, select PyInstaller from the list here, and then go to install. Once PyInstaller installs on your computer, it did in my case, so I can go to the terminal. First, try to make sure that the program is working, so maybe try to run it as you normally do, so it seems to be working. In my case, I have no errors. Therefore, now we're ready to go to the terminal and type in PyInstaller space --one file window ed space clean, and then lastly you want to say GUI.py, or at least in my case, so this should be the name of your main file, so the file which you usually run your program. So that's GUI.py in my case. That's what I run when I right click here and go to run GUI. So PyInstaller is the library we installed, and now we can execute it from the command line. So this is not the Python console. Note this is the terminal. These are Linux commands, so we can run this on the Linux operating system, not on the Python interpreter. Right, then one file means that the executable will be one file. It can run as one single file, as opposed to creating multiple distributed files. So it's simpler to give people one single file. This will avoid having to create a terminal window on the side of the GUI. So when the user runs that executable, they don't want to see the terminal also, they only want to see the GUI. So that makes it possible. And then clean, this makes sure that if you executed this command previously, then with this flag, when you supply that flag, the previously generated executable will be overwritten. So that's also good to have, and yeah, press enter. Now, you might get an error as I did in here, and this suggests to install those packages on Ubuntu. So I'm on Ubuntu here, therefore I'm going to do sudo apt get install Python 3.10, because I'm using 3.10, so I'll do Python 3.10 -dev. So that command there approximately. Press enter. Enter your Linux user password. Here you need to press Y and then press enter. And that seemed to be successful. And now I will press my upper arrow key to call that previous command, which was this one, and I'll execute that again. So the PyInstaller command. Right, it says that building was successful, and we should be able to find the file inside dist in here. I'll right click over dist and then go to open in files. So that should open the file explorer, and that's the file that was generated. So I'll double click that, and there we go, that's the program. As you see, todos.txt was also generated when the program runs for the first time. So if you add now a to-do here, it's going to be successfully added in the list box. You can exit, so the to-dos are stored in this text file. You can give to other people this file only, and so a todos.txt file will be generated for them, so it will serve as their own database. And that was about how to generate Linux executables from Python programs. That ends this video. We were able to cover 3 operating systems, so thanks a lot, see you later.